Right, inter-VLAN routing. We saw you can do in three ways. One, giving a dedicated interface for each broadcast domain on a router. Two, you create a trunk link between the switch and the router. You create a trunk link and use the router as a routing device and switches forward the traffic to the router. You see, I'm going to have a connection in between these two. This is going to be a trunk. Also, this is going to be a trunk. And I'm going to have some computers in this LAN here. And also here. We are going to have two VLANs. Let's say VLAN 10 and 20. And that I'm going to replicate using VTP. I'll configure here VLANs. 50. I'll configure it on switch 2, and the replication will happen to switch 1. And I want this to be VLAN 10, and this to be VLAN 20. And this is going to have 10.0.1 as IP. As IP address. Now for the 10 subnet, we need a gateway. So we'll create a subinterface G0/0/0.1, and this will be VLAN 10. And on the other side, VLAN 20 with subinterface.2. And the gateway address will be .10 and .20. The VLAN number I'm going to give as the host identifier. And we also know both for VTP and also for this communication, trunk is needed here and here. Yeah, let's begin from the left here. This is going to be the IP address on the sub interface. Okay. And here, this is what going to be the gateway address 20. this. Right. Now, if you ping from this device, it will ping because they're all in same VLAN called VLAN 1. Definitely this will ping this because it's same layer 3, same subnet. Likewise, 20001 will ping 20002, but there won't be inter routing. In between these two routers, the communication won't happen. We need a router support. Fine, but let us have a proper design. Even if someone changes the IP address to 10003 here, the communication should not happen. So we need to put them in VLANs. For that, we are going to have VTP. Now I'm starting from the right, the VTP configuration on switch 2. VTP, okay, yeah, VTP mode. Server is default, let it be default. VTP name, domain name, 1, 2, 3. And then interface between the switch, which is F01, switch port mode trunk. And the VLANs, VLAN 10, name 10, VLAN 20, name, just some name I want to give that 20. All right. Now, let's go and check the other switch. Hostname switch underscore 1, show VLAN brief. All right, we need to put the same domain name, VTP domain. Show VLAN brief. Okay, it has come as soon as you put the domain name proper, it has come. Next is what? Next is assigning the interfaces, allocating the interfaces to the VLAN. Interface F0/2 in switchboard mode access, switchboard access VLAN 10. You see here, sorry, 3, not 2. 2 should be trunk. 3 should be 10. Switchboard mode trunk. So I have finished configuring trunk on the link that goes to the upstream router. Now, interface F0/3 switchboard mode access, switchboard access VLAN. Okay. Interface F4, I believe. Yeah, this one is 20. Let's verify. Show VLAN brief, you can see F03 is a member of VLAN 10 and F04 is a member of VLAN 20. This membership has to be done manually on both switch. So I go here and put the interface F02 VLAN 20, F03 VLAN 10. Okay, 0/2 is VLAN 20. F0. Okay, let me change this. Okay. F02 is VLAN 10. Switch mode access. Switch mode access VLAN 10. And all right, done. So the membership is given between the devices of same VLAN. The reachability is guaranteed, no doubt. Only between different VLAN members, the ping won't happen unless and until I finish configuring the router. Let's verify first pinging. From here 10.0.0.1, I would like to ping 10.0.0.2. But what I cannot do is I cannot ping 20.0.0.1, which is very next device, because they're on two different broadcast domain and also through two different layer 3 domain. Both layer 2 and layer 3 are different. Simply means they are in different broadcast domain. Now, we need router support for providing reachability between these two devices. What happens actually is, as we already spoke, every traffic should go through the router. Sometimes you may be pinging from A to D. Traffic cannot go like this. It goes from here, processed, get processed and routed, processed, processed, and go here. Sometime I may be talking between C and D. Traffic has to go processed, go processed, go processed, come back on the same path processed, come back on the same path processed, and go here. That's a drawback. But there is no other go because there is only one router here. Let's do. I have finished configuring trunk on this side. Let's go verify that first. I should see two trunk ports. Show interface trunk. You can see F01 is the trunk port. What happened to the other one? Even though I have configured, it is not listed here. The reason is the link is down. The protocol, line protocol is down. You see, we have already configured the trunk on that port. Switch port trunk is configured both on. Okay, one is auto-negotiated. You saw that in the output. One is auto-negotiated. We have already configured on two. But it's not appearing there. As I said, the other side of the link is down. Line protocol is down. Let's go bring it up. It's a fresh router. Enable host name. I'll give a name as inter VLAN routing. And interface G000. Bring it up. Now you will see two trunk links in the switch. Earlier it was only one. So the second one is trunking because we turned on trunk manually. Let us now enable the routing part. interface f0 / sorry g 0/0/0/dot 10. You see, dot one is what I wrote in the book. You see, the physical interface is already up. I already made it up. You saw me doing that by typing no shutdown on the physical interface. Only after that you should go to the sub interface. Without saying no shutdown, you can definitely create this interface. You can put IP address, everything fine, but what is not fine is unless you put no shutdown on the physical interface, these virtual interfaces cannot operate, won't function. So first you bring the physical interface up, then you create the sub interface. Because it's a virtual interface, you no need to say no shutdown for this virtual interface. They automatically come up if physical interface is up. And then you cannot straight away give IP address like this. It won't accept. Why? Because it's a sub interface. Switch will be there on the other end and the router knows it. Because it's a sub interface, definitely switch will be on the other side providing the trunk support. But if the switch is on the other side with the trunk, then router should attach a tag value. So it won't allow you to assign IP address until you say what tag this interface should use, or what tagged traffic this subinterface should process when the switch forwards the traffic to the router. Switches are going to forward with a VLAN tag. When a tagged traffic comes, you need to tell that this subinterface G001 will be responsible for all the traffic that is coming from 10 subnet. So for that identification marking, we need to say encapsulation .1q VLAN 10. That's it. And then you assign IP address. It is going to accept it silently. Next, interface G0/0/.2. Same story, encapsulation .1q20. IP address is 20.0.0.20. Done. Now let us verify by typing show IP interface brief and then check the routing table. You should have routes to these two subnets. And now if you will ping from here, it will ping using the tag value. This is the device connected to the directly connected switch to the router. This is the other switch. Yeah. So you can also reach from here 20.0.0. Done. No, but this is not the inter-VLAN routing. Let us go for inter-VLAN routing now. I'm going to ping from this PC to this PC, A to B. Very next PCs will ping. Earlier we were not able to ping. And if you trace the route, you can see it goes to the router and comes down. It goes to the gateway, which is the router's address 10.0.0.10, and comes down. I can also ping 20.0.0.2, which is on the other switch. Now let's trace route. Two only I traced earlier. Fine. One also same. Sick. Okay, now we are able to ping and trace route from here to the other VLAN member on the other switch as well as the local switch. This is inter-VLAN routing. And what next we are going to see is we are going to attach a layer 3 switch to this itself. We are going to have again inter-VLAN routing on this one also. For that I'll take two computers only, VLAN 10, VLAN 20. VLAN 10, VLAN 20. And then what we are going to do is we are going to connect the router and we are going to do normal routing here. So if you want to have a routing, you can have routing here, or you can even have a SVI for this one also if necessary. But let's go with routing 30 here. And now this is going to be VLAN 10, but it's not the same VLAN 10 which is on the other LAN. Why? Because there is a break in the broadcast domain here. This is not a trunk link. I'm not going to use this as a layer 2. So here the subnet cannot be 10 or 20. It should be like 40. Right? Do you want anything else other than this? Is this okay, or you have some other idea? Let me know. You want to do SVI here? No problem. You can do that. Then you have to create a sub-interface here. You have to create a sub-interface here, and you need to put in different VLAN. All right. So my plan is to enable EIGRP for routing between these networks. So these two interfaces are going to be layer 2 interface, F01 and F02. And because this is a multi-layer switch, I want to show that an interface can also be a layer 3. So I have this here. And I also want to show you that the EIGRP protocol can also run on this multi-layer switch. At the end of the lab, we should be able to ping from this 10.0.0.1 to 50.0.0.1, 40.0.0.1, 20.0.0.2, 10.0.0.2, and 20.0.0.1. Let's begin from the left. I'm going to this router here, the old router. Interface, the new interface name is G001. IP space address is 30.0.0.1. And I would like to run EIGRP. I say router EIGRP alpha. Router EIGRP. Okay, this is the older version only supported here. No problem, let's put 10. Then I say networks are 10 and 20. 30 also should add. Okay, so now we have show IP, IGRP interfaces. All these three are running. 2 sub interface and 1 physical interface that connects to the multi-layer switch. Check the routing table. You will have routes for all the directly connected. Okay. Now there is no other thing need to be done on this router. Let's go to this multi-layer switch. We don't need a trunk on this link, on the switch. There's no need for a trunk on the switch. We are doing routing in between these two. In case if I would have had an SVI here, means many members of 30 on the switch, there is another VLAN, then I would have created an SVI, make this as a member of a trunk. But we don't want to do it now because we want to make sure that switch also supports layer 3 IP on the physical interface. That's why I put like this. But you can also try that by making this as a layer 2 port and having SVI, same as you're going to have SVI for this too. Because we already have 2 SVIs, I did not go for the third one. Now, enable config T interface F03 has got IP address. F0/3 no chat IP address. It won't work because it's by default layer 2 port. We say no switch port to bring layer 3 and then put the IP address 30002. And next is interface VLAN 10. Though I don't have a VLAN 10 interface, VLAN 10, I can still do this. No switch port, no needed because it's already a layer 3. No shutdown. That's important. And I put IP address as 40.0.10. And then interface VLAN 20. By default, it is up only. You don't need to say no switch, no shutdown actually. This is an optional one. If VLAN is created, it will come automatically up. Because I did not create VLAN called 10 and 20, I'm just showing you by putting this no shutdown. Still, the interface did not come up, you see. That VLAN is mandate. Even though I have said no shutdown, you don't see the interface coming up. That is what you should know. If you don't have the VLAN, it won't come active. You see, it's not active. Let me go and show you that. Show, okay. IP routing is the command to see the layer 3 running. RYUTING. Check the routing table. You don't see 40 and 50 subnets. But the moment you create VLAN 10, the interfaces come up. VLAN 20. Again, the line protocol did not come up because you don't have any members for this VLAN. You see, we don't have any members for this VLAN. That's why the line protocol did not come. How it will come if there is no line in first place? So let's put some interface to 10 and 20. That is 10, F01 is 10, F02 is 20. Switchboard mode access, switchboard access VLAN 10. See, now only line protocol comes. Interface F0/2 switchboard mode access switchboard VLAN 20. Switchboard access VLAN 20. Okay, now you will check the routing table, you will find the route there. Show IP route. You have the route for 40 and 50. Now running EIGRP. All right, the neighborship has come. So the route also would have come now. Show IP route, you have the route for 10 and 20 also. All that I need to do is I need to give IP address to this PC with a gateway address and start verifying the reachability. The IP address that we wish to give here is 40. 40.00.10. Verify the IP and move on to the next one. Done. Now I can ping from here any one. 10.0.0.1. I'm able to ping. 20.0.0.2, which is the other side of the LAN. We are below the router on a stick. So I'm able to ping from here to this one as well as this one. Likewise, from here I can ping 50.0.0.1, trace 50.0.0.1. It goes to the router on a stick and goes to the layer 3 interface of the multi-layer switch and then to the destination. I can also ping 40.0.0.1. Yep. Right, so if you trace route now, and you will see the same path. The destination is what only the difference. Same path, 10.0.0.10 and then 30.0.0.2 in destination. So this is what the inter-VLAN routing using router, using multi-layer switch. In our next class, we'll start. Yeah, tell me, please. Okay. Show IP interface brief. You will see on the VLAN interface these two IP addresses. Now, on the trunk, this is the inter device that is layer 3. 1 and 2 are in VLANs. These two are in VLANs. show VLAN brief. Right. Welcome. Any questions?